In this tutorial, we are going to find the set of values of x that satisfies two inequalities together, which means that we are going to solve two inequalities and represent their solutions on the number line to determine the set of values that satisfies the two inequalities together. For this objective, we will solve exercise 3, part A, from set of exercises 3D on page 34. Where in this exercise we have two inequalities and we have to find the set of values of x for which the two inequalities will be true. Now, as for part A, we have two inequalities and we have to solve each inequality separately. The first inequality is 3 multiplied by x minus 2 greater than x minus 4. Since we have parentheses, I have to expand the equation. So 3 multiplied by x gives us 3x, and 3 multiplied by minus 2 gives minus 6, which is greater than x minus 4. Now we will gather the x's on one side, so we take them to the left side. Then we get the x from the right to the left side and change the sign to the negative. Since we changed the position and is greater than minus 4, and because we changed the position of minus 6, its sign will be changed to a positive sign and it will be plus 6. Now 3x minus x equals 2x greater than 4 plus 6, which is plus 2. To get the x by itself, we have to divide both sides by 2. When we divide 2x by 2, we get x greater than 2 divided by 2, which is 1. Note that if x has a positive sign, the sign of the inequality remains the same. So the set of values of the first inequality is x greater than plus 1. As for the second inequality, we have 4x plus 12 is greater than 2x plus 17. So 4x minus 2x, because we changed the position of 2x from the right side to the left side, its sign changes from positive to negative. We do the same thing with greater than plus 17 minus 12. And again, because we changed the position of 12 from left to right, the sign changes. So it becomes 7 minus 12 equals plus 5. To get rid of the coefficient 2 multiplied by x, we are going to divide both sides by 2. Since we are dividing both sides by a positive number, the sign won't change. We will get x greater than 5 over 2, which is 2.5. So the set of values of the second inequality is x greater than plus 2.5. Now I will take the two solutions that I got, which are x greater than plus 1 and x greater than plus 2.5. On the number line, we will plot the values. First, we plot the 0 and continue plotting till I reach plus 3. And because I have small values, the scale will be every 2 squares is equal to 1 unit. For the first inequality, we have the set of values of x is greater than plus 1. Since we have greater than without equal, so I have to draw on the value plus 1 a hollow circle. Since we have greater than, we have to complete the arrow by dragging it as we see here. So from this circle, I will go ahead to the right of the value plus 1. This is the set of values for the solution for the first inequality. For the second inequality, we have the set of values of x greater than 2.5. Since the value is 2.5, which is between 2 and 3, and since there is greater without equal, so we draw on 2.5 a hollow circle and go ahead to the right side of 2.5. After drawing the two directions for the set of values of the two inequalities, now we are going to find the region of intersection between the blue and red lines. Notice that this is the region where the two lines intersect. So the intersection region is all the values that are found in this part. The intersected region is the same as the one determined by the red line. So x is greater than 2.5. So the required set of values is x greater than 2.5. Since I have opened a circle, I cannot take it. So in this way, we can notice that the set of values may be given in the form of x greater than 2.5. It is not necessary that the solution is always bounded between two values as we have solved in the previous tutorial. So once we just draw the solution on the number line, we can determine the solution that achieves the two inequalities at the same time.